Lesson C11, it's the bottom of that last page that you just finished doing with our arithmetic sequences. We're now looking at linear inequalities with two variables. If you are looking in your textbook, this is section 6.5. So as we finish up our unit with linear functions, it says I should be able to define linear inequalities. What is the half plane and the boundary? I can graph linear inequalities on a coordinate plane resulting in a boundary line, which will either be solid, that's when you have your greater or equal or your less or equal, or dashed, less than or your greater than, and shade the half plane. So you're going to see graphs now where we are looking, and you might see a dotted line, and if it's greater, you're going to shade everything above that. You might see your y and x axis, and you might see a solid dashed line going in this direction, has a negative slope, and it says less than, and you would then shade everything below. But you might also, when you look at these, see a line in your y and x coordinate that is a horizontal line, and it's a dashed line. That's when our y equals a zero slope, and you shade below. So you'll also encounter some different ones in these different situations. So it says if you're buying paperback books and hardcover books for sale, you can spend at most $20. So can we spend more than 20? Probably not. So how are we going to be writing that as an inequality? That's going to be our less or equal to $20. We can't spend more than 20. What possible combinations of paperback and hardcover books can you buy? So our paperback, we're going to use P for paperback. How much do they cost? This is our standard form of an equation, 2.5p, plus our hardcover, we're going to use H. And how much does each of them cost? $4.50. So thinking about the different forms of equation, this is where standard form comes in very nice, instead of slope, intercept, and point slope. What are some solutions that we could have? And I want you to think about this. What if we have, as you are looking at this, what if we have, so we have paperback is our P, and our hardcover, that's really our X in this case. So paperback is P, and H, hardcover, is our Y. If we have no hardcover books, take 20 and divide by 2.5, you should have 8 paperbacks. You could have 8 paperbacks and no hardcover. All right, well, what if we get one hardcover book? How many paperback could we have? So remember, if you'd be solving this, you'd put 2.5p plus, we've just spent $4.50, and it has to be less or equal to 20. So you're now going to subtract 4.5 from both sides. And if we subtract 4.5 from both sides, we got $2.50. 2.5p is less or equal to, we should have $15.50. We're going to divide by 2.5. And how many books could we at most buy? Remember, you have to buy a full book. This is going to be discrete. You would have 6 and 1. So what I would like you to do is try and think of some of the other possibilities. Think about if you have 0 paperbacks, how many hardcovers? And you should be able to come up with a couple more points. So pause the video and try and figure out what these other numbers are going to be, and then start it up again and you'll kind of see what those are. Should be 0 and 4. If we have 2 hardcovers, we might have 3. Remember, you don't have to spend exactly 20, so could you have 1 and 3? Yeah, you probably could. Could you have one that comes out nicely is 4 and 2, but could you have 2 and 2? So there's many points that are solutions to this, and there's no way we want to try and list them. So this is where graphing inequalities comes in really nicely. So a linear inequality of two variables formed by replacing the equal with an inequality. What are we talking about for our inequalities? That's going to be our less than or our greater than. It's going to be less or equal or greater or equal. The solution to the inequalities is still going to be that ordered pair, x comma y, that makes it true. The graph of an inequality in two variables has a dot on every ordered pair that is a solution. So you can think of it as having a lot of dots in there. And sometimes we'll do shading, but a lot of times it might just be the dots. So the question is, kind of like we were thinking about that last situation, is this ordered pair a solution? So if I'm looking at 1, 2, remember this is x, this is y. So is 2 greater than 1 minus 3? 2 is greater than negative 2? Yes, it's a solution. If we are looking at this problem and we have x again and y, is it a solution? So we're going to put negative 7. So we are going to put negative 7 is greater than, and now we're going to put our x, which was a negative 3 minus 3. So is negative 7 greater than, and again remember subtraction can be rewritten as plus a negative 6. And if you think about that, greater number, so here's 0, here would be negative 6, here's negative 7. Is negative 7 greater than negative 6? No. It says list one other solution that would work. If we're looking at another solution that would work, you just need a number that makes this true. And I want you to think about that because there are many, many, many that make it true. Could we go with 5 greater than 4 minus 3? Yes, 5 is greater than 1. So our ordered pair would be 4, 5. Can you come up with more of them? Is 5, 6 going to work? And you can try many of these to see if they will actually make it true. As you take a look at how do you graph an inequality, hopefully at this point from the graphing worksheet we did this last week, you are getting down all of your equations, but it says graph include every point in the solutions, and there's an infinite number of solutions, and they're not always on the line. Rather than drawing thousands of dots, we have a shortcut, and that's when we start shading. When we graph a boundary line, it's either solid. When do we have solid? Greater or equal, less or equal. Or a dashed line. So if you're thinking about those dashed ones, that's going to be our less than and greater than. And it's based on that inequality. And then we shade the part that includes the solutions. It's either going to be on one side or the other, and the part that you shade is called the half plane. So when we look at this equation, we read this as a less than or equal. If it is less than or equal, less than is usually below the line. So when we look at this, we are going to shade everything below. Where did we start? We started at our y-intercept 1. We did down 3, a slope of negative 3, 2. So you're always going to still graph this like an equal sign, and then you go back and decide should it be a solid line or dotted, in this case solid, and then where is it below. Now, the other thing that you're going to hear us talk about is a checkpoint. Easiest checkpoint you can use is 0, 0. Should 0, 0 make this true? It looks like it's in the shaded part. And if we do that check, so make sure you write this down, the check is 0 less or equal to, 0 times this will be 0, plus 1, is 0 less than 1? Yes, we shaded in the right area. Take a look at this one. When you read this, it says y is greater, not greater or equal, just greater than 3/2 x minus 1. Usually for greater, we are thinking above the line, and it doesn't matter which way our line is slanted. This would be greater on this one. This would be the less. So greater is shaded above in gold. Because we started at 0, negative 1 with a slope of up 3 and over 2, and up 3 and over 2. So as we are looking at those, that's how you're looking at that graph. And in this case, we shaded above that graph. So at this point, we started at the negative 1, up 3 and over 2, dotted line because it had a greater than, and we shade above. Now again, this is our nice, easy checkpoint. So always picking that checkpoint like we did those first couple of questions, that checkpoint of 0, 0. Now you can always pick other points, but 0 is the easiest one. And the question is 0, going back to this equation, greater than 3/2 times 0, which is still 0 minus 1. Is 0 greater than 1? Yes, so we should shade above. How do you graph linear inequalities? Well, it's nice. Graph the equation for y equals. So again here we're thinking that our slope is 1 over 1 and our y-intercept, our start point was at 0, negative 2. So we start at 0, negative 2. We have a slope of 1, up 1 and over 1. At this point we're not drawing a line because we're going to go back here and we take a look and we say, oh, if we look at this it is a greater, which means it should be a dashed line. So we are now going to make this dashed line and we can fill in all these points and we have a dashed line. And now it says it is greater. Now we think greater should be above, so we think we're shading here, but we're going to try a checkpoint. So decide which side and then pick that test point. And our test point we think is 0, 0 makes it true. Go back to your original. Y is greater than x minus 2. Is 0 greater than negative 2? Yes. So we are going to shade all of this because every single point in here is actually a solution. I want you to try the next ones. Remember, special case, getting ready for our test. When is it vertical? When is it horizontal? Try it, pause the video, and when you turn it back on, you'll hear me explaining it. Again, x greater than negative 1. First think of graphing x is equal to negative 1. Again, that means along this line, this vertical line, we are going to have a dashed line. If it is greater, where are the numbers greater than 1? Well, 0, 1, 2. And if you pick the checkpoint, is 0 greater than negative 1? Yes. Y is greater or equal to 2. Oh, y is greater than equal to 2. Should be thinking horizontal. No other, just one variable. So we're looking at all the points where y is 2. And in this case, it is a solid line. Where is everything greater than 2? Well, it doesn't make sense to be where 0 is. 3, 4, and so we are shading everywhere above that line. You're now going to have some situations when you're looking at the solution, and you're going to be looking at, again, standard form. So a party, you can spend no more than $12. Okay, no more than 12. Less or equal to $12. You could pay 12, but you can't spend more. Peanuts cost $2 for P. Could you use, in this case, if you're looking at the graph and how they set this up, could you use 2x? And x is really our peanuts. And then we are looking at the cashews, which for C, or if you had 4y, is less or equal to 12. And when you're thinking about this graph, you might want to think, what are our intercepts right away, right? So if we are looking at our intercepts, when x is 0, what is our y going to be? So 4y, you'd have, is less or equal to 12, which means when we divide by 4, less or equal to 3. So we have this point at 0, 3. That's our y-intercept. What's our x-intercept? Oh, our x-intercept. So remember when we did that earlier, this is kind of where it comes in handy. So now we're graphing 0y. If we wanted to do that, if y is 0, we're going to end up with 2x is less or equal to 12. If 2x is less or equal to 12, we should have 6. Now, because it was less or equal, we're going to have a, see how tricky this is to draw this nice straight line without a straight edge. And we are shading all of these in between. Can we buy a fraction or a decimal of a pound of peanuts? We can. So we don't have points here. We have all of this shaded because we can have more than, this is kind of continuous. There's tons of answers that we can get. So now as you finish up, before you come into class, I want you to look at this and make sure for problem 5 that you did multiple choice, which one matches it, and be ready to explain why. Okay? And then on the next page of your notes, that last page, take a look at the graphs, and we will look at these solutions in class tomorrow.